So quiz number 1, all we're doing is we're adding vectors together. How do we add vectors together? Draw them. And if we subtract vectors with a bit of cleverness, we can turn it into an addition question. Joss, can you get that door for me? Actually, I forgot to shut that. Thank you. So vector A plus B, this is what I'm looking for you to get the mark. An arrow there. For you to get the mark, I need to see something pointing this way with an arrow on the end of it. That's vector A plus B. Looks like it's about a 45-degree angle-ish. Instead of going down, I'm going to go straight across to number 6. By the way, what is 7 plus 3 in your head? What's 3 plus 7 in your head? When you're adding, does the order of adding matter? Same answer. What is A plus B? A little slanty one going down at a 45-degree angle. What's B plus A? I bet you it's going to be a little slanty one going down at a 45. Let's see. This time it wants me to draw vector B first. Okay. Then it wants me to draw vector A. Okay. And the resultant is going to be from the tail of the first to the tip of the second. Hey, yeah, looks like I got pretty much the same shape. I do. 1 mark. Now, if you want to, you can label these as A and B, B and A, and you can call this the resultant. Right now, I'm just interested in, can you get the shape? C plus B. I'm adding vectors. How am I going to add 2 vectors together? Draw them. So vector C, that. Vector B looks like that. There's the resultant. That's all I'm looking for as a shape. Now, if I wanted to calculate the resultant, I would probably have to break this guy up into components. And I could, but I didn't ask you to calculate. I just said, can you draw what the resultant should look like? This gives you a way to kind of imagine what the answer should look like. Number 7 is B plus C. I bet you it's going to look the same as C plus B. Let's find out. Vector B goes down. Vector C goes that way. And the resultant is like that. Hey, yeah, those two look the same. Is that okay? Number 3, vector A plus C. Okay. There's vector A. There's vector C. There's the resultant. There's the resultant. And again, if I wanted to calculate it, I'd break that up into components, but I'd need numbers and angles. I didn't give you any of that. A plus B plus C. I can't. Oh, what I can do is go A plus B, get an answer, and then say, well, no, you know what? If I want to draw these, I can draw them tip to tail, tip to tail, tip to tail. So let's see what that's going to look like. There's vector A. There's vector B. There's vector C. There's the resultant. It's going to look like that. Number 4, A minus B. Oh, we're subtracting vectors. How do I subtract vectors? I don't. What am I going to do instead? Well, I'm going to add the opposite. How? Plus, well, you know what? Let's write it a bit bigger. I'm going to do vector A plus negative vector B. Vector A looks like this. What does vector B look like? Pointing which way? Down or south? What would negative B, negative down, negative south look like? Up. You know what? I should have imagined this better, because if I draw it here, I'm going to run into stuff. So really, I should have drawn A down here, and then vector negative B, that there, pointing up and right is A minus B. Number 9, vector 2A. You know what? 2A is A plus A. A plus A. There. That's 2A. Twice as long as A. And now I just taught you how you multiply a vector by a scalar. What would 3A look like 3 times as long as A? Same direction. B minus A. B minus A. Okay. That's going to be the same as B plus negative A. Vector B is down. Vector A is to the right. What would negative vector A be? That way. Number 10. A plus B minus C. Well, that's going to be A plus B plus negative C. Okay. A. B. Now, vector C goes that way. What would negative vector C be? Instead of down and right, up and left? Oh! You know what my resultant is? I think I get back to where I started from. I think this is actually 0. This is like 2 people pushing A and B and a third person canceling out the force. The net force is 0. Or this is like you walk direction A, you walk direction B, and you realize you forgot something at home, you go back home to grab what you missed. Any questions there? Can you give yourself a lovely score out of 10, please? Make sure your name is on them. No, you know what? Hey, make sure your name is on it. Can you pass them inwards? Person in the middle, put them in a nice, neat pile, all facing the same way. Last day, we looked at a review of kinematics. It was lesson 4. We reviewed good old VF equals VI plus AT. VF squared equals VI squared plus 2AD. And D equals VIT plus a half AT squared. I gave you some questions to try. I hope number 1 and number 2 were pretty good. Number 3, medium good. You had to find something, a little yucky. I'm thinking 6. Well, no, 6 was good. I'm thinking starting 7, 8, 9, and 10, there were some questions. And so I will say, hey, any questions from the homework from last day? Now is your chance to ask. I've been helping a bunch of people during the flex blocks too, I know. Any of these? So you just want to be cautious. Don't fall way, 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 way behind. Okay. Yeah?
Could you do number 9?
Number 9? Sure thing. Number 9 is really wordy. I stole this. I added number 9 this year. I came across a handout, interesting conceptual physics questions, and some of them were pretty good, and so I stole this one. And the reason I kind of like this, I thought, okay, is because, hey, VI isn't 0. We're not dropping. All right, number 9. When in doubt, DULP, draw a little picture, DFIC, list your data. I don't know what to do here. First thing I'm going to do is write down what they want me to find. What do they want me to find? VF. All righty. I see that the time to fall is 2.5. I know that if we're in free fall, it's good old negative 9.8. What am I going to write for that? I'll give you a hint. Not 22. Negative 22, because we are going to end up below from where we started from. Now we're committed to vector land. Sorry, I said VF equals 0. What I should have written is VF equals question mark. Sorry about that. That's why you were staring at that. I don't have an equation that has T, A, D, and VF in it. I do have an equation that has those guys and VI in it. And it seems to me if I find VI, then I can go plug and chug. So even though this question is saying find VF, you know, I'm going to spend most of my time finding VI. The question clearly says VI isn't 0. In fact, it seems to imply that VI is going to be positive, that this thing is on the way up. So if I get a positive answer, yay. Duncan, have I got an equation that has those in it? Yeah. He's thinking. Yeah. VIT plus, and because I know I'm going to be rearranging this, I'm going to write it as a 0.5 AT squared. Out of all the ones to rearrange, this is probably one of the more complicated ones, but we want to get the VI by itself. Okay. What's going to drop down like a domino? Yep. Okay. Now what? Minus the 0.5 AT squared. And that's going to give me, just visualize this in your head, VIT. How would I get the VI by itself? Yeah, so you can visualize that hopefully in your head and go like that. Is this a fraction? Yeah. More than one thing on the top? Yeah. Brackets. More than one thing on the bottom? No. Okay, no brackets. This should give me VI. Let's see. So it's going to end up being negative 22 minus 0.5 negative 9.8 2.5 squared all over 2.5. If I carefully crunch this, keeping track of brackets and things and not being sloppy, oh, and making sure the 22 is negative, I'll get negative 22 minus 0.5 times negative 9.8 times 2.5 squared divided by 2.5. Oh, there we go. Apparently 3.45 on the way up, meters per second. Really quickly then, in theory, it's going to be that plus negative 9.8 times 2.5. Hey, yeah, that is the answer. Negative 21.1. That would be fair game as a A- level multiple choice question, but I wouldn't make it this wordy on a test. But a two-stepper like this, in particular, Drake, having to rearrange the D equals VIT with a half AT squared, which is the yuckiest one to work with, is now fair game as a challenge. Okay. Any other questions from the homework? What did we get? Oh, peppers? Okay. If you want some, help yourselves later on. We'll pass them out. Any others? Okay. Again, I'm around after school, or hit me up during a flex. The only thing you guys should know, block H is my prep, so flex block H, I'm not around. Sorry. If you have lesson 4 done, would you be so kind as to hand it in back there in block A, please? Otherwise, projectile motion. I'm going to spend a lot of time on this. We actually finished off last year with this, but this is going to be the bulk of the written section of your test. I'm going to talk about your test. Your test is still not for a bit. It's not going to be the end of next week. It's probably going to be the middle of the week after, is my gut. And it's going to have some vector questions, but the written section is going to have 2 or 3 projectiles and then 1 river or airplane question. And we'll talk about that more as we get closer. So projectile motion. A projectile is an object in free fall. We studied one-dimensional projectiles an awful lot last year. Have I mentioned lately I jumped out of an airplane? Now that we've learned vectors, we can study two-dimensional projectiles. I hoped to get this in last year. I sort of did, but hopefully now I'm going to repeat it in better context. Here's our first thought experiment. A mass is held at shoulder level and fired horizontally. Which curve best shows the path that it follows to the ground? Path A, straight down, path B, path C, or path D? Once again, we're going to vote. Once again, how high you hold your hand up is how sure you are of the answer. Who says A? It's got to be A, Mr. Duke. No one. B, Mr. Duke. It's got to be B. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And I loved the peer pressure votes. There was about 5 of those that came up after looking around. C. It says C. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Is that a hand up?
Yeah.
12. Who says D? Okay. So it looks like you guys are pretty clear that it doesn't fall straight down, and it doesn't travel in a straight line and then come to a stop. By the way, we have a special name for this one here. When I was growing up, we called it Roadrunner Physics, because in the Coyote and Roadrunner cartoons, he would always run out off the cliff, come to a stop, and it was only once he realized that there was no ground that he would fall straight down. That's not how real life works. So B or C, convince me. Again, you can convince me that you're right, or that you can convince me that someone else is wrong. You can attack or defend. Convince me. Duncan, what did you pick? You want B? Okay. So you're going to defend B is right, or you're going to attack C is wrong?
Defend B is right.
Convince me.
The force of gravity takes effect immediately. It doesn't take a second to take effect. So
Oh, hear the wisdom. Do you hear what he said? As soon as it leaves the gun, the projectile is in free fall. Now, part of the problem is you've been lied to by the movies. The movies have taught you that bullets go in a straight line. They do not. They do not. Bullets start falling right away. They start falling right away. So when you see, and I think I've told you this last year, the classic is the sniper, where they show the image through the scope, and the image through the scope always has the crosshairs lined up right on the target. It's garbage. If that's all you needed to do, any idiot could be a sniper. All you got to do is get the crosshair, done. Actually, the further away they are, the further above the target they have to aim, and they have to know how high above the target to aim to compensate for the fact that the bullet's going to fall a certain distance to hit the target. B. Defend your answer. Gravity acts instantly. There's no delay. C is what movies have sort of taught you. Actually, you know what? Movies have taught you that it's kind of D. It just keeps going in a straight line. Right? Is that okay? Here's what I want us to realize. Let's vibrate. So we're okay with that, although you could go airplane pie if you really wanted to. Projectiles can be thought of doing 2 things: free fall and moving sideways. There's a word for that. It begins with letter C and rhymes with opponents. Okay. So, example 2, another thought experiment. 2 identical objects are held at the same height above the ground. One object is released and falls to the ground at exactly the same time. Object 2 is projected to the right, and it also falls to the ground. Which one hits the ground first? Option A. The first object, because it's falling directly to the ground, straight down. B. The second object, because it's got a velocity, it's moving faster, so it's going to reach the ground faster. Or C. They both hit at the same time. Once again, we're going to vote. Once again, how high you hold your hand up is after you have the answer. Who says, so again, what we're imagining is, go back to my little Nerf dart gun, and if at the same time as I pulled the trigger, I dropped the dart at exactly the same time. A, B, or C. Who says, A, Mr. Duke, object 1 is traveling less distance, it'll hit the ground faster. A, I'm telling you, A. A, no one. Who says, B, Mr. Dewick, object 2 has an initial velocity, so it's got some velocity, it's got some kinetic energy, it'll get to the ground faster. Who says C? Put your pencils down, look up. I think recording. There we go. So explain your answer using relevant concepts of physics. Well, both fall the same. I'll write dy, that's my shorthand for it, vertical displacement. Put a vector there. Both of them, what's their initial velocity? Vertically? 0. Nope. So they also have the same Vy initial, which is 0. What else is the same for both of them vertically? Same Ay. Well, if you have the same D, and you have the same Vi, and you have the same A, therefore, you're going to have the same T, because D equals Vi T plus a half AT squared. If all three variables are the same, the fourth variable is going to be the same. I'd take that as an explanation. By the way, you could also have made up reasonable numbers and crunched the numbers like we did last day, but here, we did this one a little more algebraically. Okay. Again, what this shows us is that the horizontal and vertical components, motions, are independent. They don't affect each other. What happens horizontally doesn't affect what happens vertically, and vice versa. And here is the key idea. Horizontally, what's the horizontal acceleration of any projectile? Who remembers from last year? When you launch something horizontally, when you launch anything at an angle or whatever, horizontally, what's the acceleration? Yeah. And the reason is, if we ignore air resistance, and we will, there's no force acting on it. Horizontally. Vertically, yes! But I'm telling you, the vertical and horizontal are independent of each other. If I had fancy schmancy, turn the page. If I had fancy schmancy equipment and I looked at a stop action or a strobe picture of a projectile, what you would notice is that horizontally, every time I took a picture, let's use the highlighter, Mr. Dewick, each horizontal distance would be the same length because it's traveling at a horizontal constant velocity. The vertical distances, Kayla, will increase because vertically it's speeding up in the negative direction. But horizontally, constant. And that's what gives you that path. Is that all right? Have I convinced you? As a picture then, Vx equals constant, and you can write down here because Ax is 0. Vy changes because Ay is negative 9.8 meters per second squared. Not 0. Not 0. I don't know why I have give reasons for your answer. I don't know. Don't know what I was getting at there. What does that mean? Well, let's keep talking. So here's the stop action picture of the projectile below. At each point along the path, it says, indicate the velocity components. I did the first one for you, and in fact, I'm going to zoom in a little bit. So there's the first one. What can you tell me about the horizontal velocity component? Changing or always stays the same? You know what? Let's draw all those in. So I'm going to say, there's Vx. I'll make it the same length as that original. There's Vx. I'll make it the same length as the original. I'm eyeballing it, but I'm trying to make it the same length as the original. There's Vx. Trust me, put the Vx on top on the final one if you get a chance to. You don't have to, but it'll just be easier. The horizontal component is going to be the same the whole time. What about the vertical component? On the way up, what's happening to the vertical speed? Slowing down. On the way down, what's happening to the vertical speed? So I think right here, I think right here, will I draw just as big a component? A little smaller. There's Vy. What about at the very tippy top? What's the vertical component? 0. That doesn't mean the velocity is 0. It's still moving sideways. You know what it does mean? At the top of any projectile, v equals vx for a split second. The overall velocity just happens to be the horizontal velocity because that's the only component that still exists. Then it's going to be downwards. And are we at the same height as we were back here? Then we'll be at the same speed but pointing down. In other words, I'll eyeball it, but I'll try and draw it about the same length as I did that previous one. And when I hit the ground, my vertical component will be the same as my original vertical component, because what goes up must come down, but negative. So I'll draw it the same length, but pointing down. Is that right? About like that? And then, Julie, if you wanted to, I'm not going to, I'm going to, but don't mark up your diagram. The resultants would be, not quite that far, Mr. Dewick. The resultant would be there. The resultant would be there. But I don't want those on my diagram to clutter things. Oh, I knew I was going to do that. Okay, let's try this a little bit more here. Erase. There we go. Okay. If it seems like I'm repeating myself, it's because this is really, really crucial. Now we can start to make some assumptions for projectiles. It says, indicate the velocity components on the stop action picture. We already did that. Oh, did we answer all the questions? B says, what happens at the top of the trajectory? Vy equals 0. So the total velocity just happens to be Vx for a split second. What can be said about the projectile just when it's about to hit the ground? V final equals negative V initial. If you're starting on the ground and you're ending on the ground, what goes up must come down. Is that okay, Joel? Thumbs up? Okay. Example 5 says indicate the velocity components and then fill in the key facts about the two-dimensional projectile motion. At the top, what can you tell me? We did the components already up there. We may draw some in here, but what can you tell me at the top? Vy is equal to what? 0. And so really, all you'd have for a component would be whatever Vx was. Is that okay, James? If we break this original up into, well, let's be consistent, Vx and Vy, when you're even with launch, you still have Vx and Vy will be the same as the original, but pointing down. If you want to generalize, Vy initial equals negative V final when you're at the same height. What if you keep falling then? If you keep falling, is it going to speed up or slow down vertically? So we can't say that just before impact Vf is equal to V initial negative. Just before impact, what can we say? we must solve for Vy final. A will be negative 9.8 meters per second squared, and then we'll either use Vf equals Vi plus At if we know that, or we'll use Vf squared equals Vi squared plus 2Ad and square root. The only issue is if you use that second one, if you use Vf squared and square root, it'll give you a positive answer. Look at the picture. Is Vy positive when it hits the ground? You'll have to insert, you'll have to include the negative yourselves. So horizontal speed is constant. Why? Because Ax is, horizontal acceleration is 0. Is the vertical speed constant? What's the opposite of constant? Vertical speed is changing because Ay is negative 9.8. Nice. And again, horizontal and vertical motions are independent, separate components. Now we can start to solve stuff. I think we'll get this one done. We might get one more done. I don't know. We'll see. Find the flight time and the range of the projectile. I showed you last year, if you give me a projectile, my strategy is what I called a T-table, where I break things up into horizontal and vertical. And in fact, last year I said there were two things that I always wrote down. I called them no-brainers. I mean, they're not no-brainers in that you need to know some physics. But now that you know it, the two things that I always write down under horizontal, what's Ax? 0. What's Ay? Negative 9.8. I do that almost without thinking. The rest I customize to the question. So take a look at this picture. Are we launching at an angle or are we launching horizontally? That makes this easier. If we're launching horizontally, then Vy initial is what? 0 for a split second. And the most common mistake, kids don't like that 0. The 20 in there, but look, the 20, which way is that arrow pointing? Vertically? No, Vx is 20. What else do I know? Now it's going to vary from question to question. It looks like they gave me the cliff height. The cliff height is 50. Height, vertical or horizontal? Vertical. So I can put a 50 there. Why is that wrong? Because it is. Okay, negative 50 because we are ending up below from where we started. Drake, how many pieces of information do I have in the horizontal column? How many in the vertical column? I'm going to solve this vertically. I'm now committed. I'm going to find t. Remember I said we're going to spend most of our time finding time. No, we're going to spend most of our time finding time, unless they tell it to me. Now, if they had given me this distance, I'd put it here. I'd find t horizontally, because I'd have 3 pieces there. So I want to find, first thing, time of flight. Okay. Let's call this part A. Let's call this part B. And because I'm going to do this vertically, I'm going to put part A over here, and I'm going to go t equals question mark. I'm looking for an equation that has VI, A, D, and T in it. There is one. D equals VIT plus a half AT squared. Now, because, Kayla, the most common mistake kids make here is with directions and components, I'm going to put a Y there, and a Y there, just to remind myself. Vertical, 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 vertical. Don't you dare put that 20 into this equation. And having said that, some people still will, because they just don't like having... By the way, what is VY initial in this question? Makes it easier, right? In fact, that gives us a modified equation, dy equals at squared over 2. It's a half at squared, but Robbie, it looks better just to tuck the 2 underneath like that. What do I want to get by itself? Okay, you ready? Robbie, I'm coming at you. How do I get the t by itself? Robbie, my friend, what am I going to do with the a?
Divide it.
Yeah, it's all coming back. What am I going to do with the 2?
Square it.
This 2 here. What's this 2 doing to the t? Adding, subtracting, multiplying, or dividing?
Times itself.
Okay, so if I hear correctly, I think I do finally. I think you're saying it's going to be, the d is going to drop down, and the a ends up on the bottom, and the 2 ends up in the front, and I'll go vertical, vertical. That equals t squared. I don't want t squared. Now, how to get rid of a squared? Square root. Good. And again, only one, Sarah hasn't had me before. I'm good with that much work, or even less. If you can do straight from here to there in your head, more power to you. On a test, of course, Michaela, I would show more work because I don't want to make a mistake. But in your homework, if you can do steps in your head, that's becoming an expert. I'm great with that. Time is going to end up being 2 times negative 50 divided by negative 9.8. Does this work out evenly? 2 times negative 50 divided by, no it won't, negative 9.8 square root. 3.19438. That. Is that right? Okay. I'm going to first of all carry extra sig figs because I'm going to use time later. So first of all, I'm going to write 3.1944. That's 5 sig figs, which would be good to go to 3 sig figs later on. But now for my answer for time, I'll go to 3 sig figs, 3.19 seconds, Mr. Dewick. Why'd you write a 3? Because you're tired. 3.19 seconds. There we go. Is that okay? All right. What did part 2 want me to find? What did part B want me to find? dx? The range? Okay. I can't. I only have 3 things. Or do I? Sorry? I have lots of time. Oh, you mean, you mean I know t, because the vertical time to hit the ground is the same as the horizontal time to move sideways. So you're telling me I can also put t equals 3.1944? Nice. Nice. I'm looking for an equation that's got d, vi, a, and t in it. There is one. What happened to the half at squared? A is 0. But make sure you put the right components into your equation. Time is a scalar, so it's the only one that can go in any one. The range is going to be 20 times 3.1944. I've got a good calculator, so instead of rounding off, I'm going to go 20 times answer button. In theory. Delete that, Mr. Dewick. You get 63.88, 63.9 if I go to 3 sig figs. Meters. Okay. We did that last year. There is probably, in fact, I'll replace the word probably. Well, I like this question, I like this question, I like this question. Why am I saying that? It's going to be on the test, right? It's going to be a horizontal projectile on your test. Either I will give you the cliff height and say find the range, or I'll give you the range and say find the cliff height. Example 9. What do you notice about the velocity in example 9? Is it slanty? It is? Then you know what that's a job for. We're going to break it up into components. It's going to be the same approach, except I don't think all of our V's are going to be zeros. I don't think any of our V's are going to be zeros. So it's going to be a little bit harder because some stuff won't cancel. There's 8 minutes left. You can work on the take-home quiz or any missing homework that you need to work on. Okay, we'll pause here.